Hello students, once again welcome to Bholanath Academy. In this video students, we are going to see the chemical properties of alkyl halide and aryl halide, that is elimination reaction. Okay students, in last video students we have seen the substitution reaction. In this video students we are going to see elimination reaction. So elimination reaction of alkyl halide and aryl halide. Elimination reaction, it is also called as dehydrohalogenation. D stands for removal of hydrogen and halogen from the alkyl halide is called as dehydrohalogenation. Alkyl halide, the alkyl stands for R and halide stands for X. When alkyl halide having at least one beta hydrogen, we are going to take the which type of alkyl halide? It should carry at least one beta hydrogen. That alkyl halide is boiled with alcoholic solution of potassium hydroxide, that is KOH. It undergoes elimination of hydrogen atom from beta carbon and halogen atom from alpha carbon, resulting the formation of alkene. As hydrogen and halogen, hydrogen we are showing with H and halogen we are showing with X, is removed in this reaction, that is why it is called as dehydrohalogenation. Okay students, now we are going to take the alkyl halide students. Say for example alkyl halide containing beta hydrogen. So here students, carbon is tetravalent. So this is the alkyl group students, where the halogen is attached to this carbon. So where the halogen is attached, this carbon we call as alpha hydrogen, and next to alpha hydrogen the carbon is called as what? Beta carbon. Okay students, this is alkyl group students. So we are going to select the alkyl halide when alkyl halide having at least one beta hydrogen. So this beta carbon is containing hydrogen, this is called as beta hydrogen. Okay students, so we are writing in general students, dehydrohalogenation reaction we are writing in general. So we have selected the alkyl halide containing beta hydrogen. When it is boiled, when this alkyl halide is boiled with alcoholic KOH and just boiled it, undergoes elimination of hydrogen from beta carbon. This is the hydrogen, is called as beta carbon hydrogen, and the halogen, this halogen is the halogen from alpha carbon. Both are removed in this, so we call as dehydrohalogenation. So when alkyl halide having at least one beta hydrogen is boiled with alcoholic KOH, it undergoes elimination of hydrogen and beta hydrogen atom from beta carbon, this is hydrogen atom from beta carbon, and halogen atom from alpha carbon, resulting in the formation of alkene. So what happens when this hydrogen is removed and this halogen is removed? So one electron, electron will come here and it will form the bond. It will form the bond that is called as alkene. Okay students, so this way there is a formation of alkene. So what happens students, when you are using alcoholic KOH, there is a formation of hydroxyl, this is also called as OH minus. Here we are representing in general, that is base containing two lone pair students, OH minus. This minus I have shown like this. So what happens students, this base will abstract the proton, only the proton. So these two electron will migrate here and they will form the double bond. And what happens students, this halogen along with this bond, it will come out. So there's a halide ion will come out and there's a formation of BH. Understanding students? So when the BH will form, then the halide will remove. So this way students, there is a formation of alkene. Alkene is formed from this alkyl halide, that is here we have taken in general alkyl halide. So this alkyl halide should contains beta hydrogen. Why it is called as beta hydrogen? Because this carbon, beta carbon, whatever hydrogen is attached to beta carbon, that hydrogen we call as what? Beta hydrogen. So understanding students? So this is the base students. Alcoholic KOH will provide the base in general, I have taken like this. So there is a formation of BH and halide will remove and there is a formation of alkene. So this formation of alkene we call as what? From the substrate. So now our substrate is converted into alkene. This is because of the dehydrohalogenation. Because of the these hydrogen and halogens are removed from the alkyl halide. That is why this is called as elimination reaction, because this substrate eliminated hydrogen and halogen. After elimination, it will form the alkene. That is why it is called as dehydrohalogenation reaction. Understanding students, it's very important. In dehydrohalogenation, the preferred product is alkene. Whatever product is formed, that is alkene, which has greater number of alkyl group attached to double bonded carbon atom. So understand, once you got the alkene students, which one is the preferred product, which will be present in major quantity and which product will be in minor quantity, that depends upon the alkyl group. That depends upon the alkyl groups to double bonded carbon atom. Understanding students? Say for example students, here we are going to take the example. So what happens students, suppose you have secondary butyl bromide students, you can write like this.
This is the 4 carbon. Bromine is attached to second degree carbon, so this is secondary butyl bromide. This is also called as secondary butyl bromide. Fill the valency with hydrogen, CH3, CH2. This is 1 carbon, 1 hydrogen, and here it is what? Now this is your alkyl halide, students. So this is alkyl halide, that is secondary butyl bromide. What happens, students, when you do the elimination reaction in presence of alcoholic KOH and just heat it, students? What happens, students? You will find two types of product. Understanding, students? There is a loss of beta hydrogen. So here, students, this hydrogen is called as alpha hydrogen. Here you have two types of hydrogen. This is beta 1 hydrogen, and this is what? Beta. Understanding? If hydrogen is removed from here, what happens, students? The carbon-carbon double bond will be formed like this. If there is a elimination of hydrogen from this carbon B1, so what happens, students? The carbon-carbon double bond will form like this. Understanding, students? Now methyl CH3, and here will be the methyl. So this alkene is called as but2ene. What happens, students, when the hydrogen is coming from this beta hydrogen? So there is a formation of carbon-carbon double bond here, and what happens, students? This will be the, so there you are forming but1ene, but1ene. There is a formation of alkene. This is the which type of alkene? but1ene. Understanding, students? Now fill the valency with hydrogen, CH2, CH2. Okay, students. So now which product will be the major, students, that we are here, where we are going to prefer the product? Which here we are going to get two products, but2ene and but1ene. So which product will be the major product and which is the minor product, students? So now, students, between these two double bond you have only ethyl. Understanding, students? So here we are talking about alkyl groups. Only one alkyl groups are attached here. So this will be the minor product, students. This will be the minor product. Preferred product will be the minor. And now here you have two alkyl group. So this will be the major product. Understanding, students? So which alkene will be the major? So this but2ene alkene will be the major, and but1ene alkene will be the minor product. Understanding, students? This is all about the dehydrohalogenation of secondary butyl bromide. Understanding, students? So this way, students, alkyl halide is converted into alkene. So two types of alkenes we are getting here, that is but2ene and but1ene. So but2ene will be major product and but1ene will be the minor product. Saytzeff elimination is preferred formation of more highly stabilized alkene during the elimination reaction. So, students, whatever product is formed, which product will be the more highly stabilized alkene, that was explained by Saytzeff scientist. That is why it is called as Saytzeff elimination. Talking about the product, so which product will be the most stable, that was explained by the Saytzeff scientist. That is, it is also called as Saytzeff elimination. Say for example, students, when carbon-carbon double bond, this is the product, students, after the elimination reaction you are getting alkene. So here, students, your example I have taken, that is the ethene. Now what happens, students? This will be the less stable product as compared to carbon-carbon double bond, students. Now if it is attached to the CH2, one of the hydrogen here, now we are going to replace with alkyl group. Out of two, students, now one hydrogen is we are going to replace with alkyl group. So this mono substituted alkene, this is the one alkyl group we have substituted, that is, it is also called as mono substituted alkene. This is mono substituted alkene will be the more stable. This product will be more stable as compared to ethene. Understanding, students? Now what happens, students, if one of the hydrogen you are replacing from this side here, students, by alkyl group, carbon-carbon double bond, students. So this will be the more stable than this mono substituted. This is di. We have two alkyl group. That is why it is called as what? Di-substituted alkene. Di-substituted alkene will be more stable product as compared to mono substituted alkene. Understanding, students? This way, students, you increase the stability of the alkenes. So stability this way is go on increasing. Understanding, students? So, students, you can say here also, you can say C carbon-carbon double bond, when both the hydrogen we are replacing with alkyl group. This is tri-substituted alkene, students, which is more stable as compared to di-substituted alkenes. Understanding, students? And this is also when all the hydrogen of the alkene is replaced by alkyl group, is we are replacing with alkyl group. So this will be the more stable product. Understanding, students? So this way, students, they have explained the stability of the alkene in elimination reaction. So that is why Saytzeff elimination reaction is very important, students. Sometimes in examination they are asking what is the Saytzeff elimination reaction. So this way, on the basis of elimination reaction, so this way you can explain the stability of the alkene. The reaction of alkyl halide with active metals. Now here, students, active metals we have taken magnesium. Reaction with magnesium. When alkyl halide RX is treated with magnesium in dry ether as a solvent, it gives alkyl magnesium and halide. So RMGX, you can say this is nothing but Grignard reagent. In general, students, alkyl halide react with magnesium in presence of dry ether. What happens, students? This magnesium will inserted between these two bonds. There is a formation of RMGX, which is nothing but Grignard reagent. This is alkyl group, so we can say alkyl. This we can also read as a alkyl and magnesium, and this is what halide. In general, students, in common name we call it, this was discovered by Grignard scientists. So the name of this compound alkyl magnesium halide we call as Grignard reagent. This is also called as Grignard reagent. Understanding, students, which is very important. Grignard reagent, students. Say for example, students, you can take methyl chloride. Example, students, if you are taking methyl chloride when react with magnesium in presence of dry ether, there is a formation of methyl magnesium chloride. Understanding, students? So this is the Grignard reagent, students. Grignard reagent are very active compounds. They react with water, hydrogen of the water compounds containing hydrogen attached to the electronegative elements. Grignard reagent, students, mostly react with the hydrogen of the water or any compound. Say for example alcohol, phenol, whatever. Example, students, this is your Grignard reagent RMGX. React with hydrogen of alcohol. Hydrogen of the alcohol. What happens, students? There is a formation of this part is going to be react and it will form MgX and OH. And what happens, students? This alkyl will react with the hydrogen of this. This is CH3, students. Now it will form RH. This is the formation of hydrocarbons. So what happens, students? This is partial negative charge, students. Now hydrogen, this hydrogen will react with this part, students. This is, they will form the hydrocarbons. One more example, students. Second example, RMGX Grignard reagent when react with ammonia. What happens, students? It will form the hydrogen of ammonia react with alkyl group and form hydrocarbons, and you will find MgX and NH2. So this way, students, you can prepare hydrocarbons, which are very important, students. Hydrocarbon preparation is very important. We are using in as a fuels, so these hydrocarbons are very important. Second reaction, which, students, we are going to see, that is Wurtz reaction. When alkyl halide react with metallic sodium in dry ether as a solvent and form higher alkanes containing double the number of carbon atom present in alkyl halide. Whatever alkyl halide, if suppose alkyl halide is containing 1 carbon, so compound, the hydrocarbon which is formed, that will contain twice double number of carbon atom. It will contain 2 in number. This reaction is called Wurtz reaction. So higher hydrocarbons you can prepare. That is why this scientist name is very famous, students. Wurtz reaction. Understanding what happens, students, in general, you can say when 2 molecules, now here 2 molecules of alkyl halide will react with 2 atom of sodium in presence of dry ether. And what happens, students? This 2 alkyl will join and form 1 molecules of alkyl. Okay, students? And there is a elimination of 2 molecules of sodium hydroxide. There is a formation of 1 molecules of containing double the number of carbon. Now here this molecule is containing only 1 carbon, so this will contain, this molecule is containing now 2 carbon. Understanding? Double the number of carbon. Say for example, students, in example, students, suppose you are taking C2H5 methyl bromide. Methyl bromide, students, this molecule is containing 2 carbon. Now what happens, students, when it react with sodium metal in presence of dry ether? The reaction is taking place in dry ether, students. What happens, students? These 2 molecules of now ethyl bromide will react with 2 atom of sodium and it will form C2H5, that is 4 carbon atom. This there is a formation of hydrocarbons. Now when you see the number of carbon in this hydrocarbon, there will be 4 carbon. Understanding, students? There is a formation of 4 carbon. That is why this reaction is very important, students, for the formation of hydrocarbons. Reactant side, you have 2 carbons in 1 molecule. Now here you are having 4 carbons. Understanding, students? That is why this reaction is very important in the formation of hydrocarbons. And there is elimination of sodium bromide. This sodium react with bromide. Understanding, students? So this way, students, you have got the molecule that is called as butane. This type of alkene, that is butane. Here there is a formation of hydrocarbon that is containing 4 carbon. Understanding, students? That is why this reaction is very important, students. When a mixture of 2 different alkyl halides is used, all the 3 possible alkanes are formed. 3 different types of alkanes when there is a mixture of 2 different alkyl halides. Say for example, students, here we are taking methyl bromide and ethyl bromide, C2H5 Br. Okay, students, 2 different alkyl halides we have taken, students. This is methyl bromide and this is ethyl bromide. Now what happens, students, in presence of sodium and dry ether? What happens, students? You will find 3 types of product. There is a mixture of 3 possible combination you are getting, students. So 3 types of product if you are getting, students. What happens when only this one reactant will combines with this reactant? So there is a formation of carbon-carbon bond that is called as ethane, CH3CH3. Okay, students. So one of the product will be ethane. Now what happens, students, when this ethyl bromide will combines, it will form C2H5, C2H5, that is butane. So product may be butane or ethane. Suppose these two alkyl halides are reacting, it will form carbon, 3 carbon, students. So here CH3, it will be CH2 and CH3. There is a formation of propane. So these are the 3 types of hydrocarbons, you can say, that is simple hydrocarbons. We are taking alkanes are formed. Understanding, students? So 3 different types of alkanes are formed. When you are taking a mixture of 2 different alkyl halide, all 3 possible alkanes are formed. These are the 3 possible alkanes, that is ethane, propane and butane will be formed. When you are taking alkyl halide, this is methyl bromide and this is what? Ethyl bromide. So these are the 3 different types of product are formed. Okay, students, now we are going to see the reaction of haloarenes that we are representing with ARX. Understanding? This is aryl halide. You can also say aryl halide, or you in IPAC name we called as haloarenes. The reaction of haloarenes with metals. What happens, students? A reaction of aryl halide, that is ARX, react with alkyl halide, that is RX. So reaction of aryl halide with alkyl halide and sodium metal in dry ether to give substituted aromatic compound known as Wurtz-Fitting reaction. So here, students, we are taking aromatic as well as aliphatic, both the type of halide when react, what will the product will form, that is we are going to see, that is also called as Wurtz-Fitting reaction. Say for example, students, we are taking aryl halide. Here, students, we are taking bromobenzene. This is the structure of bromobenzene, students. This is aryl halide react with alkyl halide, that is we are taking here alkyl halide will be methyl bromide, students, CH3. So students, the reaction of aryl halide, this is aryl halide with alkyl halide in presence of sodium metal, students. You have to take solvent as a ether, dry ether. The reaction, all the reaction will carried out in solvent, that is ether. You will find there is a formation of this group. Now will be substitute. This bromide is substituted by methyl. Understanding, students? That is why we give substituted aromatic compound. We are going to form substituted aromatic compound. So this is the aromatic ring, students. Now this bromine is substituted by methyl group. That is why we call it substituted aromatic compound. This is nothing but toluene, very important solvent, students. And there is a elimination of sodium bromide. One bromine from here, other is here. So you are getting 2 molecules of sodium bromide. Understanding, students? This way you have got the substituted aromatic compounds, that is called as toluene. Understanding? That is why this reaction is very important, students. In case of only one aryl halide, if you are taking only one aryl halide, that is ARX, takes part in the reaction, the product is biphenyl. And the reaction is known as fitting reaction, only the fitting. If one type of aryl halide we are taking, so only one name will be there, that is fitting reaction. Understanding, students? Say for example, students, so if you are taking one type of alkyl, say by here chlorobenzene, aryl halide we are taking, that is called as chlorobenzene, students. So this is aryl halide, students, in presence of sodium metals, dry ether. Now in what happens, students? This sodium will react with the halide and it will form 2 molecules of sodium chloride. Now we have to fill the valencies. So this way, students, it will be the 2 molecules of chlorobenzene react with 2 atoms of sodium and it will form sodium chloride, and you will find 2 benzene ring will be attached like this. 2 phenyl group that we call as biphenyl. So this way, students, you have got the biphenyl as a compound. Understanding? So that is why this reaction is called as fitting reaction. So what is fitting reaction, students? So only one type of aryl halide. Mind well, we are talking about aryl halide. Take part in the reaction, the product is biphenyl, then this reaction is called as what? Fitting reaction. Understanding, students? Very important for board examination. They will ask 2 marks question. This way, students, you have to represent the answer. Now, students, we are going to see nucleophilic substitution of haloarenes. This is also called as haloarenes, is also called as aryl halide. Understanding, students? Now, students, if you want to do the nucleophilic substitution of aryl halide, the low reactivity of aryl halide is going to react very slow. Is due to the resonance effect. Why this aryl halide is react very slowly? Because of the resonance effect and sp2 hybridized state of carbon. Thus nucleophilic substitution reaction involving the cleavage of carbon and halogen bond in haloalkane proceed with very difficult. Why, students? They are going to eliminate this halogen of the aryl halide is going to be substituted very slowly because of resonance effect and sp2 hybridized state of the carbon. And what is the resonance, students? Say for example, students, if you are talking about the aryl halide, that is chlorobenzene, students. This is the aryl halide, students. Now when you see the resonance of this chlorobenzene, students, you will find there is a 5 structures, students. This is your normal, chlorobenzene. So students, 5 structures you will get. Resonating structure, students. See how you are going to draw the resonating structure of chlorobenzene, students. So first to draw 5 structure of benzene. If you want to draw, this is alternate double bond and this is the chlorine is attached here. Okay students, chlorine is attached to benzene. This is called as chlorobenzene. Chlorobenzene. What will be the possible resonating structure of this chlorobenzene, students? How you are going to draw? So this way, students, you have to draw the resonating structure. This is, so what happens, students? Chlorine here, these are the lone pairs of the chlorine, students. This is chlorobenzene. What happens to when these 2 electrons will migrate here? So these 2 electrons will shift like this. So there will be negative charge, students. Now this electron is shifted here to carbon and chlorine. There will be double bond like this. So this will be the positive charge, students. This chlorine, carbon and chlorine. Now chlorine will be the positive charge. Understanding, students? Now this will be the first resonating structure. Okay students, now what happens, students, when this electron will migrate here, this will migrate here. So this will be the negative charge and this will be, so this way, students, you can draw the resonating structure of chlorobenzene. Okay students, now what happens, students? This again, this electron will migrate here. So this double bond will migrate here. So here it will be negative charge. Okay students, carbon chlorine, they will double bond. So this chlorine will always carry positive charge. Now again, students, this will migrate here. This is the first resonating, this is second resonating structure, this is third resonating structure. Now what happens, students? This again will migrate and you are getting chlorobenzene like this. So these are the resonating structure that I have drawn, students. Because of these, students, they are very stable molecules. That is why they are not going to follow the nucleophilic substitution reaction because of this nature. Carbon and chlorine bond will very small, so very difficult to substitute this chlorine from this phenylcation. This is also all are we call as here to here. These are nothing but phenylcation. They are very stable molecule, students. That is why there is a low reactivity. The compound aryl halides are very stable. That means there will be low reactivity. So low reactivity of aryl halide is due to the resonance effect because of resonance and sp2 hybridized carbon. This carbon is sp2 hybrid. The nucleophilic substitution involving cleavage of carbon halogen. This is the halogen and this is carbon. Presence of electron withdrawing group. If there is a presence of electron withdrawing group at ortho para position, it will increase the reactivity of haloarenes, that is aryl halide, towards the substitution of halogen atom. If there is an electron withdrawing group present in the aryl halide, students, so it will increase the reactivity of aryl halide. Greater the number of electron withdrawing group, withdrawing group at ortho pi position, greater is the reactivity. Understanding, students? If there is a more electron withdrawing group, the reactivity will go on increasing. Say for example, students, first example, students, if you have, this is your chlorobenzene, students. Now students, if you are having one electron withdrawing group, students, that is called as NO2 at para position. This is called as para nitro chlorobenzene. So students, number of withdrawing group is 1. Only 1 electron withdrawing groups are there, students. So what happens, students? Because of this electron withdrawing group, the substitution reaction will take place, students, in presence of NaOH. Now OH minus of NaOH, now it will be act as a nucleophile. Understanding, students? This will be negative charge. Okay students, in presence of acid water, what happens, students? Aqueous NaOH, that is why we have used water. Now there will be chlorine will be substituted by this OH minus. So you are getting substituted product will be here, the chlorine is substituted by OH minus, nitro group will be as it is. Okay students, so this way, students, you have got the product as para nitrophenol. Now what happens, students? Only one electron withdrawing group, that is NO2, is there. So there is a formation of para nitrophenol. What happens, students, if there is a 2 nitro group? So I have told number of electron withdrawing group as go on increasing, the reactivity will very fast. So this is, so if there is a one more nitro group is attached to this, what happens to the reactivity, students? It will increase the reactivity of. So students, you have second as the number of electron withdrawing groups are increasing. So this is your chlorobenzene. Now if electron withdrawing group NO2, now I am increasing. So this is 2 electron withdrawing group, students. So this is nothing but 2,4 dinitrochlorobenzene. This react very fast with sodium carbonate. Just heat it, acidic water, students. So what happens, students? Now this chlorine will substitute by OH minus and it will form the product like this. Okay students, there is a substitution reaction is taking place students, that is why it is called as nucleophilic substitution reaction of aryl halide, and your nitro group will be as it is. Okay students, this is nothing but 2,4-dinitrophenol. What happens students if there is a 3 with electron withdrawing group students? This is chlorobenzene students. Now if there will be 3 nitro groups are present here students, so substitution reaction will be very fast students. Just warm it, acidic water will containing OH minus. Now it will substitute the chlorine very fast and it will form the product like this, OH. Chlorine is substituted by OH minus and other groups will be as it is. So this is nothing but this is 2, 4, 6, 2, 4, 6, 2, 4 and 6. So that is why it is called as 2, 4, 6 trinitro chloro, which is converted into 2, 4, 6 trinitrophenol is formed. Understanding students, this is very important students. Electrophilic substitution reaction in aryl halide. Electrophilic substitution reaction in aryl halide. In the resonance structure of chlorobenzene, the electron density is relatively more at ortho and para position. Therefore, electrophilic group is more likely to attack at this position. Therefore, electrophilic substitution reaction occurs very slowly. So, because of the resonance structure of chlorobenzene students, electron density is more at ortho and para position. Therefore, electrophilic group is more likely to attack this position. Electrophile will attack to the ortho and para position of chlorobenzene. Say for example students, halogenation of aryl halide. If you are taking aryl halide students, any example students, here we are going to take the aryl halide, that is chlorobenzene. This is not simplest aryl halide students. So halogenation of aryl halide students, what happens students when you pass the chlorine gas to in presence of anhydrous, the reaction chlorination will always take place in presence of anhydrous ferric chloride, and just heat it. What happens students? Chlorination will take place. Understand, there is a chlorination of chlorobenzene and it will form one more chlorine now going to attach to ortho position. So there is a formation of 2 types of product, that is one will be ortho and one will be the other chlorine will go to the para position. Understanding students? So this is 1,2-dichlorobenzene and this is 1,4, 1, 2, 3, this is 4th position, so 1,4-dichlorobenzene. Understanding students? So here the chlorines are very far away, so this will be the major product students and this will be the minor product. Understanding students? If you are getting 80% of 1,4-dichloro will form and 20% of 1,2-dichlorobenzene will form. Understanding students? And there is a elimination of HCl. Okay students? So this way students you have got the halogenation of aryl halide, whether it is taking place ortho and para position. So this is para chlorobenzene, that is 1,4-dichlorobenzene and it is 1,2-dichlorobenzene. So 1,4-dichlorobenzene will be in major product and 1,2-dichlorobenzene will be in minor. Okay students, now we are going to see the nitration of aryl halide. Nitration of aryl halide. Here students, very simple example I am taking, that is chlorobenzene. What happens students? This is the chlorobenzene students. When react with the HNO3, when you add concentrated HNO3 in presence of concentrated sulfuric acid and just heat it, what happens students? There is a formation of 2 types of product. So chlorine will be as it is students. This NO2 now react it at ortho position as well as what para position. So NO2 will be here, and if it is ortho position it will be here. This is ortho and this is what, para. So you are getting 1 chloro, 4 nitro, 1 chloro, and this is what, at 4th position there is a nitro group, so you can say 1 chloro 4 nitrobenzene, and here students you will find. Now what happens students, out of these 2 products, this will be the major product, this will be the major, and this will be what, minor product. Understanding students? Now students we are going to see the sulfonation of aryl halide. Sulfonation of aryl halide. So here students, very simple aryl halide that I have taken, that is chlorobenzene students. Do the sulfonation, SO4 when you add concentrated sulfuric acid fumes, what happens students? You will find 2 types of product. One will be the ortho, other will be the para position. Okay students? So this chlorine will be as it is students. Hydrogen now is going from ortho, now it is replaced by SO3H. This is the sulfonyl group students. Now it is going to attach to ortho position and here it will attach to SO3H. So this will be the 1 chloro benzene sulfonic acid, and this is opposite direction students. This will be the major product students and this will be the minor. Understanding this way, you can do the sulfonation of aryl halide. Fourth reaction of aryl halide, that is called as friedel reaction of aryl halide. Now in friedel reactions, you have alkylation and you are adding acyl group. If you are adding alkyl group to this aryl halide, we call as alkylation. If you are adding acyl group to aryl halide, we call as acylation. Say for example, students, suppose you have chlorobenzene, students, this is chlorobenzene. Now we are going to, if you are going to add alkylation, you have to add the alkyl halide CH3. Okay, students. Now what happens, students, in presence, this reaction is always taking place in presence of anhydrous aluminum trichloride. Now what happens, students, this methyl, whether it is going to attach to ortho or para position. Now what happens, students, your chlorine will be as it is. You are getting two types of compound. So if methyl is going to attach to this ortho position or it is going to attach to the para position. So methylation of chlorobenzene is taking place, students. So this is called as 1-chlorotoluene. This is nothing but toluene, students. So you can say 1. Again, students, this is at 4 position, students. If you start counting, so this is called as 4-chlorotoluene. So this will be the major, students, major, and this will be the minor product. This is called as friedel alkylation. We are going to attach the alkyl group. That is why this to the reactant, that is para chlorobenzene. This is chlorobenzene. So that is why this reaction is friedel alkylation. So friedel reaction is divided in two parts. If you are adding alkyl group to the chlorobenzene, it is called as friedel alkylation. Now if you add the acyl group, students, for acyl group, students, suppose you have chlorobenzene. If you add acyl group, for acyl group, students, you have to take the reactant. Second reactant will be acetyl chloride, CH3CO. This is acetyl, students, the chlorine is attached. So what happens, students, this is acetyl. We are going to, this is also called as acyl. Now what happens, students, this acyl is going to add an ortho or para position of chlorobenzene. So students, two types of product you are getting. One will be at ortho position, other will be at para position. Okay, students, suppose, students, this is chlorobenzene, students. Now if it is attached, this acyl is attached to here. This is nothing but acetophenone. If it is attached to here, students, now this is nothing but, students, again this is acetophenone. Now when you take the number, students, at here it is 4th position, so we call as what? 1. So this we call as 2-chloroacetophenone. 4-chloroacetophenone. This will be the major and this will be the minor product. So this is all about the reaction of aryl halide, students. This is very important for the examination point of view. If you like my video, please share it, subscribe it. Thank you very much. Have a nice day. God bless you.